In this section, we're going to define what it means to raise something to the power 0 and to a negative power. When you talk about exponents, you're talking about repeated multiplication. So for example, if I say 2 to the first power, well, that's just the number 2. If I say 2 to the second power, that's 2 times 2, which would be 4. If I say 2 to the third power, well, that's 2 times 2 times 2, which is 8. You're multiplying 2 times itself 3 different times. 2 times 2 is 4, times 2 more is 8. 2 to the fourth power is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 more is 8, times 2 more is 16. Okay? Whenever we increase our power by 1, what's happening is our answer is being doubled. Well, sure, if we increase our power by 1, that means we're multiplying by another 2. So the answer that we had before is now doubled. And now, if you increase that power by 1 again, that 4 that you had before is being doubled to give you 8. And if you raise the power again, that 8 you had before, 2 times 2 times 2, that's your 8, is going to be doubled again to give you 16. If you double 16 again, that would be 32, and then multiply that by 2 again, that's 64, and so forth and so on. So that pattern will continue on forever. Okay? But now think about the pattern going backwards. Every time your exponent gets bigger by 1, your answer doubles. Every time it gets bigger by another 1, that 4 doubles again. If your exponent gets bigger by 1 more, again, your 8 doubles to 16. What if you go backwards? Okay, well, going forward, I double things. Going backwards, I cut them in half. So right here, if I go backwards, that would be dividing by 2. Okay? So if my power goes from 6 to 5, my answer gets cut in half. Now, let's say I do that again. My power goes from 5 to 4. Well, again, I'm cutting things in half. Half of 32 is 16. If I go back again, well, that's going to be divided by 2. Half of 16 is 8. And again, divide that by 2. Half of 8 is 4. And do that again. And sure enough, half of 4 is 2. So that pattern works forwards and backwards. Every time your exponent value increases, your result doubles. Anytime it decreases by 1, your result gets cut in half. But what happens if we keep going? And I say, well, you can't keep going, right? That's already it. You've gone from 6, 5, 4, 3, 2, 1. That's it. We're done. Well, there are numbers past that. If I keep counting down, 6, 5, 4, 3, 2, 1, the next step would be 0. But what does it mean to have something raised to the 0 power? Well, it's the same pattern. Here, I cut things in half to get 32. Cut that in half to get 16. Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. So if I follow that same pattern, what's half of 2? That's going to be the number 1. So 2 to the 0 is equal to 1. That's not only true for the number 2. This is actually true for every exponent. Look at just one more example. 3 to the first power is equal to 3. Anything to the first power is itself, right? 3 is just 1 time. It's the number 3. 3 squared, that's 3 times 3 is 9. 3 to the third, 3 times 3 is 9, times another 3 is 27. 3 to the fourth, 3 times 3 is 9, times another 3 is 27, times another 3 is 81. Notice every time my exponent value gets bigger by 1, my y value is tripling, times 3. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. But if I take that and go backwards, well then, 81 divided by 3, that's your 27. 27 divided by 3, that's your number 9. And if you take that 9 and divide it by 3, that's your 3. But what happens if I take another step? Well, then I'm going to end up with 3 to the power 0. I'm decreasing my exponent by 1 again. And the pattern is I need to divide by 3. Well, if I take 3 and I divide it by 3, I get the number 1. So notice, 2 to the power 0 is equal to 1, but so is 3 to the power 0. If we did this for 4 or 5 or 6, it's going to work out exactly the same way. So that's our definition. If we let b be some real number, doesn't really matter what it is, let b be a non-zero real number. And I say, well, wait a minute, you said it could be any number. Why not 0? Because the way the pattern works is if the base is 2, I'm dividing by 2. If the base is 3, I'm dividing by 3. If the base was 0, I can't divide by 0. That's undefined. Okay, so we have to skip that one. But any other number is fine. Let b be a non-zero real number. So any real number except for 0. Then our definition of b to the power of 0 is 1. What if I kept going? And you say, well, no, you definitely can't keep going because that's it. You've already counted down to 0. Well, after 0, we have the negative numbers. What happens if I keep going? 2 to the minus 1, 2 to the minus 2. What about over here? What if I did 3 to the minus 1, 3 to the minus 2? What are those going to be? Well, continue the pattern. Every time I take your exponent and subtract 1, the answer gets cut in half, and half, and half, and half, and half. What if I keep going? I'm already at 2 to the power 0 is equal to 1. What if I cut it in half again? Well, half of 1 it's 1/2. What if I do it again, though? Okay, well, I can take half of a half. Half of a half is a quarter. 1/4. Let me do it one more time. What if I do 2 to the power negative 3? Well, I can cut that in half again. Notice half of a quarter is going to be 1/8. But now look at these numbers. 2 to the power 0 is equal to 1. Okay, that's our definition. What about these? What do you notice between 2 to the power 1 and 2 to the power minus 1? What about 2 to the power 2 and 2 to the power minus 2? What do those numbers have in common? What about 2 to the power 3 and 2 to the power minus 3? What do 8 and 1/8 have in common? Notice they're reciprocals. 2 to the first and 2 to the minus first are reciprocals. 2 versus 1/2. Here, for 2 to the second, you have 4. 2 to the minus second, you have 1/4. 8 versus 1/8. They're reciprocals of each other. If you use that same pattern over here, you'll find the same result. Here, every time I take an exponent and subtract 1 from it, I'm dividing the answer by 3. Okay, so let me divide that by 3. Oh, okay, well, if I take 1 divided by 3, that gives me 1/3. If I keep going, I can divide that by 3 again. 1/3 divided by 3 is 1/9. And if I do that again, well, that's 1/9 divided by 3 is 1/27. But again, notice the pattern. Anything to the power 0 is equal to 1. This and this, their powers are opposites, and their answers are reciprocals. Here, 3 to the power 2, 3 to the power minus 2. This answer and this answer are reciprocals. When the exponents are opposites, positive versus negative, when exponents are opposites, the answers are reciprocals. 3 to the power 3 is 27. 3 to the power negative 3 is 1/27. Again, reciprocals. Just by looking at this, what do you think 3 to the minus 4 would be? So that's our definition. If b is a non-zero number, real number, b to the 0 is equal to 1, and b to the minus n is equal to 1/b to the n. So if I have b to the power 3, that's going to be the reciprocal of b to the negative 3, like that. So for examples, what is 7 to the power 0? Well, that's equal to 1. Okay. What is 7 to the power negative 2? Well, whenever I have a negative exponent, here's a negative exponent, that's the same as 1 over that same thing without the negative. So that's 1 over this same thing without the negative. Oh, but now I can simplify. 7 squared means 7 times 7, which is 49. So 7 to the minus second is 1 over 49. If your number is already a fraction, you're still reciprocating. Just remember that reciprocals look a little different between whole numbers and fractions. So for example, let's say I have 2/3 to the power 0. Well, again, any real number, except for 0, any real number to the power of 0 is going to equal to 1. So even 2/3 to the 0, that's equal to 1. What about 2/3 to the minus second power? All right, so we're going to reciprocate. Now, when you take a reciprocal of a whole number, you write it as 1 over the whole number. But this is not a whole number, it's a fraction. Well, when you reciprocate a fraction, the numerator and the denominator transpose. They switch places. So here, you can write this as a number to a negative is the same as the reciprocal to a positive. Okay, we'll do the same thing here. A number to the negative is the same as the reciprocal raised to a positive. Once that reciprocates, the negative goes away from the power. Same as over here. Once it flipped, once it reciprocated, the negative went away from the power. But now we can go ahead and simplify. 3 squared, that's equal to 9. And 2 squared, that's equal to 4. So 2/3 to the negative second, that's 9 over 4. So right here, this is not different, but it is a note that when you already have a fraction, so if it looks like something, so here I'm going to say A and B, let A and B be non-zero real numbers. Then if you have something like A over B, where you already have a fraction here instead of starting with a whole number, and you raise that to a negative power, that's the same as you reciprocate and raise that to a positive power. And again, keep in mind, this note is not different from this definition. It's just that's the way the definition looks when your base is a fraction. When it's not a fraction, it looks a little simpler like this. So go ahead and give this a try. Go ahead and simplify. Uh, 3 to the power 0. 3 to the power negative 4. Let's say 2/5 to the power 0 and 2/5 to the power negative 3. All right, go ahead and pause the video, give those a try, and once you have a result, go ahead and unpause and we'll go through it together. All right, the first one is the simplest one. As long as this base is not 0, any base to the 0 is equal to 1. And you know what? That's the same for this one. Any base to the 0 is equal to 1, as long as it's not 0. 0 to the 0 is undefined. It's just like saying division by 0. That one doesn't mean anything. Okay? When you have a whole number raised to a negative, that's the same as 1 over the whole number to the positive. And here, 3 to the 4th. Coincidentally, we have that over here, don't we? 3 to the 4th is 81. So it's going to be 1 over 81. All right. 3 to the 4th power was 81. 3 times 3 times 3 times 3. So that's what we get down here, 1 over 81. Now this one's already a fraction. So when you reciprocate, it looks a little different than when you reciprocate a whole number, but still the same idea. You're going to reciprocate and your power will now be positive. So it's going to be 5/2 to the power of positive 3. And now we apply that power. 5 to the power 3, 5 times 5 is 25, times the third 5 is 125. 2 to the third power, well, we had that one up here, 2 to the third power is equal to 8. And there we go, those are our results. Note that this does give us an alternate way of writing a fraction. You can write it with a negative power. So for example, let's go ahead and simplify the following. Let me go ahead and add 2 to the minus first plus 4 to the minus second. Okay. Those don't look like fractions, but they are, because after all, that's what a negative exponent is. It reciprocates these whole numbers, which will form a fraction. All right, so 2 to the minus first You're going to write this as 1 over 2. And then you're going to have, instead of a negative power, you'll have a positive power. Okay. Here, instead of writing this with a 4, since that's got a negative exponent, you can write that as 1 over 4. But now your exponent should be positive. Well, now those are just regular fractions. I can add those. Here, 2 to the first power is just the number 2. We can leave it as 2. But here, 4 squared, 4 times 4, that's 16. So to add those together, we're going to need a common denominator. Fortunately, 16 is a multiple of 2. We just have to multiply it here by 8. And so this is going to give us 8 over 16 plus 1 over 16, which is going to give us 9 over 16. 8 plus 1 give us 9/16. All right, so go ahead and give this a try. You're going to simplify the following expression. Let's see. We'll do 2 to the minus 3 plus 3 to the minus 2 plus 4 to the 0. Go ahead and give that a try. Pause the video, go through that, and once you've simplified that down, go ahead and unpause and we'll go through it together. All right, so the first thing to do is to simplify each of these, and then we can add. All right, 2 to the minus third is the same as saying 1 over 2 to the positive third. 3 to the minus second is the same as saying 1 over 3 to the positive second. Once you reciprocate, your power is now a positive. And over here, any number other than 0, any number raised to the 0 power is going to give us 1. So there we go. We're going to add those. Here, this denominator, 2 to the third, 2 times 2 times 2. 2 to the third, 2 times 2 times 2. That's the number 8. So that's 1 over 8 plus 3 to the second. That's 3 times 3. That's 9. Plus the number 1, which, since we're adding fractions, I'll write this as 1 over 1. That way they all have a denominator. A common denominator here, notice these have no common factors, so the common denominator is going to multiply those together, like that. 8 times 9, 8 times 9, like that. So this one needs a 9 top and bottom. That way it has a denominator of 8 times 9. This one needs an 8 on top and bottom. That way it has a denominator of 8 times 9. And this needs both an 8 times a 9 on the top and bottom. That way it has a denominator of 8 and 9, just like these do. All right, so here we go. That's going to give us, we have a common denominator. 8 times 9 is 72. And now let's see our numerators here. 9 times 1 is 9, plus 1 times 8 is 8, plus 9 times 8 is 72. Okay. And if you add those together, that's going to give us 89 over 72. And that's our result. Just what we needed. Another way to talk about fractions, right? Now, even though we define this using numbers, using constant numbers, this applies to variables as well. So, for example, let's simplify. We can have x to the power 5, y to the power 3 over z to the power 2, and the whole thing will be raised to the power negative 4. Okay. Now, all of our properties of exponents still apply. The fact that we now have a definition for what a negative exponent is doesn't change anything else about how exponents typically operate. So here, whenever you have multiplication and division, what you can do is you can apply this by multiplying it into the powers. Whenever you have something that has a power and you're raising that to another power, those powers can multiply together. But you'll notice that this power has a negative on it. Okay, well, that's still going to work the same way, but before we do that, we're going to go ahead and reciprocate. Because you have a negative power here, and based off of what we saw, whenever you have a fraction with a negative power, you can reciprocate and then only worry about a positive power. So that's what we're going to do. We're going to go ahead and reciprocate. That z squared comes to the top. This x to the fifth and y to the third are now part of the denominator. And once we've reciprocated, this power is now a positive 4. And now we can go ahead and apply this through each of those factors in that expression here. Z to the power 2 to the power 4, that gives us z to the power 8. X to the power 5 to the power 4 is x to the power 20. Y to the power 3 to the power 4 would be y to the power 12. Just like that. Should you happen to have any numbers, those would be handled in pretty much the same way. Let's say we have 2x squared y to the fifth, and we're going to raise the whole thing to the negative third power. Okay, well, again, whenever you have a negative exponent, you're going to reciprocate. Now, if this already looks like a fraction, that looks like we flipped this upside down. When it's not a fraction, when it looks just like a single expression like this without a denominator, then reciprocating it means 1 over that. Because, of course, you can think of this as being over 1. So when you reciprocate, the 1 comes up and this goes down. But now that you've reciprocated, the whole thing is now raised to the third power. All right. So now, just like before, this third power will apply to each of these factors separately. All right. So 1 to the third power, well, that's just going to be 1. 1 times 1 times 1 is still just 1. 2 to the third power. And as we saw before, 2 to the third power, 2 times 2 times 2, that gives us 8. And x squared to the third power. Okay, now whenever you have something that already has an exponent, and you raise that to another exponent, those exponents multiply together. So 2 times 3 will give us 6. Likewise here, y to the fifth to the third, that'll be y to the 15. And that's our result. Now, in each of these examples, we've had a negative exponent over the entire expression. It is possible, however, to have a negative exponent as simply part of the expression. For example, let's say we want to multiply together x to the power 3, y to the power 5, over z to the power 4 times x to the power minus 5, y to the power 6 over z to the power negative 3. Like that. Okay, well, the rules for exponents still work the same way, meaning we're going to go ahead and multiply things that have the same base by adding their powers. But the difference is now some of your powers are negative. Well, that's okay. We can still add numbers. They're positive or negative. We can still add them. So to multiply these two things together, they have the same base. Now, these two wouldn't go together, nor would this one and this one, because they have different bases. But here, these both have the base of x, so we can combine those by adding the powers together. So x to the power of 3 times x to the power minus 5 is x to the power 3 minus 5. You say, well, I thought you were supposed to add them. Well, I did. I'm taking 3 plus a negative 5. Plus a negative is the same as saying minus. Here, y to the power 5 times y to the power 6. Well, that's y to the power 5 plus 6. And you say, well, why didn't you make that a minus? Because there was no negatives in those. Here, 3 plus a negative 5. Oh, that minus is right there. But here, there were no negatives. 5 and 6 are both positive, so 5 plus 6. And then down here, I have z to the power 4 times z to the power negative 3. That's going to be z to the power 4 plus negative 3. Well, plus a negative, that's just saying minus. So here I can just write minus 3. Okay, so this simplifies as x to the power 3 minus 5. Notice that's a negative 2. Y to the power 5 plus 6, that's going to be 11. And then z to the power 4 minus 3, that's just z to the power 1. If you want to write 1 here, you can. If not, a z by itself without any power written, that means the same thing. Z to the power 1 is the same as z. But now notice that this looks a little different than what we usually write. We don't usually have a negative exponent in our final answer. Usually we have everything written out with a positive exponent. So what do we do with this thing? All right, first let me show you the formal way to do it, the official way, the one that uses the rules that we see here. And then we'll see why we can actually skip one of those steps. All right, so the formal way of doing this is as follows. If we were going to simplify x to the minus 2, y to the 11th, over z. All right, now, I know this is going to reciprocate. That's what a negative exponent means. So here, instead of x to the power negative 2, I have 1 over x to the positive 2. That means the same thing as x to the minus 2. I've reciprocated with a positive power. And now that's times y to the 11th over z. Okay. Now, when you multiply two things like this, remember y to the 11th, that's like saying y over 1 to the 11th. So you can just go right across. So 1 times y to the 11th, that's y to the 11th, over x squared times 1 is x squared. And then that answer is all being divided by z. Okay. See, this does take a bit of effort. Well, now, that's what's called a complex fraction, meaning a fraction that has another fraction inside of it. Okay, but here, really, you should think of this as division. You're taking y to the 11th over x squared, and you're dividing it by z. Oh, okay, well, I know how to divide. Dividing is the same as multiplying by a reciprocal. So here, instead of dividing by z, I'll multiply by 1 over z. Okay, so 1 times y to the 11th, that's y to the 11th. X squared times z is in your denominator. Okay? So that's the formal way to do it. Officially, that's what's going on. But notice what the answer is. Y to the 11th stayed right where it was. The z stayed right where it was. It was in the denominator. The only thing that changed was x to the minus second. What did it do? Well, it went down to the denominator and it lost its negative. Well, yeah, that's what we expect it to do. Remember, whenever you have something with a negative power, you're reciprocating, meaning you flip it around and it loses its negative. Whenever you have something with a negative power, it becomes part of the denominator, right? You reciprocate, flip things around, and it loses its negative. So right here, we can more easily say, you know what? That's got a negative power. That means we're reciprocating. Oh, but only that one has a negative power. Okay, so we only flip this one. It was in the numerator, so now we'll put it in the denominator. Oh, but now we flipped it. Okay, so in doing so, it loses its negative. So we get y to the 11th over x squared z. Now, notice that's the exact same answer, and that does tend to come out a little bit nicer. Okay, let's see that again. So let's see here, example. All right, let's go ahead and see that again. Let's say we have 2x to the minus 4th, y to the 7th, over z to the minus 8th, times 3x to the 7th, y to the minus 9th, over z to the 5th. All right, so here we go. We're going to go ahead and multiply. Only things that have the same base go together. All right, well, here these don't even have a base, right? They're just regular numbers. They're not exponential expressions. So let's just start with those. 2 times 3 is 6. No mystery or anything weird going on there. Now here, x to the negative 4 times x to the 7, that's x to the negative 4 plus 7. You're adding the powers. Right here, y to the 7 times y to the minus 9 is y to the 7 plus negative 9. Plus a negative. Plus negative 9. Yeah, we can just write that as minus 9. And in our denominator, z to the minus 8th times z to the 5th, that's z to the minus 8 plus 5. Like that. All right, so let's clean this up and see what we get. All right, so let me see here. That was the first example, second, third. Here's our fourth example. Okay. That's going to give us 6 times. If you take negative 4 plus 7, that's going to give us 3. 7 minus 9, that's a power on y of negative 2. And then here, negative 8 plus 5, that'll give us negative 3 as the power on our denominator. But notice you have some expressions that have negatives on them. Now again, formally, what you'll do is you will reciprocate each of these and then go through and simplify the complex fractions. But in the end, what really happens is, hey, that's got a negative on it, so we're going to reciprocate. Okay, so it's in the numerator, we'll go down to the denominator. Well, yeah, but what about that one? It's already in the denominator. What happens when I reciprocate? Well, then it's got to go up to the numerator. So here, this will be 6. That x to the third stays right where it is because it doesn't have a negative power. It's already a positive power. Here, this will come down to the denominator, and in doing so, it'll lose its negative on its power, so it's just y to the power 2. And then this will reciprocate coming up to the numerator, giving us z to the power of 3. And that's our result. So go ahead and give this a try. Go ahead and simplify. Let's do 5, x to the power of 3, y to the power of negative 2, over z to the power 4, and we'll raise the whole thing to the power negative 3. So simplify that as much as you can, and then also try this one. You're going to multiply together 4x to the minus 5, y to the 7, over z to the 9th, times 6x to the power 5, y to the power negative 2, negative 2 over z to the power negative 12. All right, go ahead and pause the video and give both of those a try. And once you're done, go ahead and unpause and we'll go through those together. All right, so let's take a look. Here, that negative exponent is going to tell us to reciprocate everything. All right, so that's going to be z to the power 4 on top. On the bottom, we have 5, x to the power 3, y to the power negative 2. So everything just flips around. And now this is all to the power of 3. Okay, now, z to the power 4 to the power 3, that gives you z to the power 12. 5 to the power 3, 5 times 5 is 25, times another 5 is 125. X to the power 3, and again to the power 3, those multiply together to give you x to the power 9. Whenever you have a power raised to another power, the powers multiply together. And then you have y to the negative 2 raised to the 3, which is y to the negative 6. Negative 2 times 3 is negative 6. Now here you still have a negative power, but it's only on this part of the problem. When it's on everything, everything flips. But when it's just on one factor, that factor flips. So that y to the negative 6 in the denominator will come up as y to the positive 6 in the numerator. Everything else will stay as it was. Z to the power 12 is still in the numerator. 125 x to the power 9 is in the denominator. And that's our result. Putting these together, let's multiply. 6 times 4, there's just regular multiplication. No exponents involved, just 6 times 4 is 24. X to the power negative 5 times x to the power positive 5. Well, when you add these together, negative 5 plus 5, that's x to the power 0. Here, y to the 7 times y to the minus 2. That's going to be y to the power 7 plus negative 2. Or in other words, 7 minus 2, that's the number 5. And then in our denominator, we're going to have z to the power Now there's a 9 plus the negative 12. Okay, adding a negative, that's just the same as saying minus. 9 minus 12 is negative 3. Now notice right here we have x to the 0. X to the 0 is just the number 1. That's the number 1. So here 24 times 1. Okay, that's just 24. So x to the 0 has gone away because it became just the number 1, which 1 times 24 will stay 24. We have a y to the power 5 over z to the negative 3. But again, since that's got a negative on it, it reciprocates, but only this part. So that'll come up into the numerator. Since there is nothing else left in the denominator, we can just write this as 24 y to the power 5, z to the power 3. If you really want to still have a denominator, you can write this over 1. But generally, once this is brought up and there's nothing else in the denominator, you just write it like this. So 24 y to the power 5, z to the power 3. And that's it. So if anybody has any questions, comments, or problems, please make a note of those and reach out. And I hope everyone has a nice day.